Since we talked about yesterday, we have partial fractions. Once again, the trig does not work. U substitution does not work. Partial fractions does. Okay, steps. Hold on. Before we even think about partial fractions, whenever we have a fraction, whenever we have a rational expression, there are a couple things to think about before we go into partial fractions. First of all, you could consider U substitution, because maybe sometimes it'll work. Maybe sometimes it'll work. You could think of splitting up the fraction. And you could think of arc trig. So I'm assuming this didn't work, and this didn't work, and this didn't work. Okay? U substitution isn't working. Splitting up, you guys know what I mean by splitting up, right? Splitting up, I mean something like, I have like an integral of 2x plus 5 all over
3x.
X squared plus 4, right?
Oh yeah.
Could try U sub, but doesn't work perfectly. I could try arc trig, but not arc trig. What do I mean by splitting up?
2x over plus 5 over.
Does it make it possible? Yeah, possible, because what am I going to use for this one? U sub. So I have x squared plus 4. I have du is equal to 2x dx, which fits perfectly, right? So then I could say, okay, this is the same thing as integral of 1 over u du plus this one 5 times, yeah, it's going to be arctangent, where I have u equals x, a equals 2, right? So I'd have 1/2 arctan of x over 2. Does that make sense, guys? Oh, I didn't finish. This would go to ln of, which is always positive, so no absolute values. Does that make sense?
Yes.
Okay. So we try U sub, doesn't work. Try splitting up, like that process over here doesn't work either. Like we have an example that wouldn't work for. Arc trig doesn't work. Okay, so what do? First of all, I have to compare degree of the numerator with degree of the denominator. Every time you have a fraction, and actually guys, this could be my step 1, and this could be my 2, this could be my 3, this could be my 4, this would be my 5, this would be my 6, this would be my 7. This one technically should always go first. Always, always, always divide when improper to simplify. Improper means degree of the numerator bigger than degree of denominator. We could actually even say greater than or equal to. I could say greater than or equal to. Might want to change. What would I do? Well, what if I had something like integral of, I'll just do a specific example to be easier, like 3x cubed over x cubed minus 1. Sure. You said x cubed, right? You did x cubed.
Yeah. So we,
Or if this was x to the 4th on top, or x to the 5th, or x to the 6th. Either way. If the degree of the top is greater than or equal to, why would I divide? Right? Then I would have
Oh, it's positives.
So how can I change this integral?
plus
I shouldn't have done x cubed, I should have done x squared, be easier, and I could do plus, then it could be arctangent. You actually don't know how to do this one yet. But if you could do it,
I thought you would give us x cubed over x squared.
oh, that's why you said x
Yeah.
cubed. I was like, oh, that would be easier, huh?
Yeah.
So this would simplify, right? That would simplify down. If I was to make it like a different example, that one, okay, you can't integrate yet. You don't know how yet, but we could change example. That'd be easier. Improper again, another way. It's up 1 power. So then I could go ahead and do 3x cubed once again, x squared plus 2. So I still have 3x, not still, sorry, 3x, right? So 3x cubed plus 6x. So I'd have a remainder of, right?
Yes.
So then that would change my integral to be integral of 3x minus 6x over x squared plus 2. Can I solve this one, guys?
Yes.
Mm-hmm. How would you solve it? That one easy, right? What would you do with this one?
Q sub. U sub.
Yeah. I would use u sub. Q, huh? I would use u sub because bottom x squared plus 2 du would be 2x. Okay, I can handle if it's only off by a constant, right? I could use u sub to solve. Okay, so anyway, long story short, remember we have fractions, we have rational functions. We're trying to integrate them. First step, divide when improper. Second step, well, it's kind of all a part of it, but look for u sub, look for splitting up, look for arc trig, right? Then, none of that worked. I'm to step 5. This is where partial fractions come in, is step 5. Partial fractions come in as soon as you start factoring the denominator because you don't know what else to do. Partial fractions come in when you start factoring the denominator, you don't know what else to do. When you factor the denominator, you could get linear factors or you could get quadratic factors. Linear factors, what do I mean? I mean, like, right? Linear factors. Even though they might be squared or cubed or something like that, linear factors, they're still lines, right, being multiplied together. Quadratic factors would be a little more complicated. Quadratic factors are if I actually have quadratics, could be to a power, could not be to a power, doesn't matter. What I'm saying is I cannot factor anymore. It's like, what do we call in math? Irreducible. Irreducible quadratics can't factor anymore. At least not while still being the real numbers. So linear are going to be linear form, quadratic are going to be quadratic form. Here's what we do. And this is denominator, right? We're looking at denominator, not numerator. So I'm factoring the denominator completely. Okay. First of all, if I need to take an n of x, like a numerator, or it could be p of x over q of x, f of x over g of x, I don't know, n of x over d of x. I am going to take whatever my problem is, and I am going to set it equal to, okay, when linear factors, I'm going to take each one, like in this example, I would have ax plus b, ax plus b squared, ax plus b cubed, and then cx plus d. This is like really bad problem, okay? But if I had a linear factor raised to a power, I have to do one for the first degree, second degree, third degree, because these could all have been put together. And then I have to think of all the possible ways that I could go from separate to together. Now, hold on, I can't just stop there. I have to say, wait, I have an unknown constant, because it's not going to be improper, because if it's improper, I should have already divided. So it's not improper. So this can't be a linear. This has to be a constant. has to be 1 degree below. Unknown, unknown, unknown. I'm going to form partial fractions. Now I still have to solve it, but this is how I set up the problem. If I need to form partial fractions for quadratic factors, okay, I would take my original problem, and I'm looking back here, just so you know which one I'm looking at just for my example. I have my original problem, my numerator, my denominator. I would have to, what would I have to do? Set ax squared plus bx plus c to the first power as 1, and then ax squared plus bx plus c to the second power for 2. Now hold on, guys. What would be 1 degree less than the quadratic? What could be on top? It could be a and b, but it could be something else too. Remember, a and b were just up here because it was 1 degree less than a, what's less than a linear? A constant. What's less than a quadratic? 1 degree less than is a line. So,
X?
like mx plus b, like a line. But ax plus b and then like cx plus d, just to get lots of variables in. So do you see the trend of you have to do 1 degree less? So line goes to constant, quadratic goes to line, cubic would go to quadratic. We're not going to have anyone's that hard, but. And the nice thing is on AP tests, they don't give you any of the quadratics. They don't expect you to be able to do this. But in homework, we might have a couple because I want to keep stretching you, preparing you for next math. None? Oh.
What's the next one?
Party poopers. In pre-cal new book. Nobody in here, well, Mandy, you were old book, but in pre-cal, they have hard ones. They have really hard ones like this. Calc 3 would be next. Calc 2 or Calc 3, depending on which college you go to. Okay, let me see, hold on, real quick. Oh, I need to write one more step. Okay. After you form the partial, silly me, you have to do what to them? Solve, right? I need to solve. I'm just going to say dot, 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 because it depends on problem, whether you might just have A and B, you might have A and B and C, you might have A and B and C and D, I don't know.
Missy,
Solve for all the numerators, yeah.
I think that example is have both factors.
Wait, which one? Linear?
Yeah. It's a kind of like both, right? Because it's 3.
Well, the 3, okay. You're thinking there's a quadratic in the cubic, and I understand that, except it could be factored more, so I don't have to look at him as a quadratic.
Yeah.
This is a quadratic that I cannot factor. Does that make sense?
Yeah.
So quadratic factors, if I can go to linear, so much easier, right?
Yeah.
If I could go down more, but this is one that's irreducible, this is one that I cannot factor anymore. But that's also why it's not on the AP test, because it's, I mean, sometimes you get them, but not very often. Not very often do you get irreducible. Okay, how do I solve simplify? Well, we looked at it yesterday, but we didn't really give steps, and it actually would be a very good idea to talk about steps. So how would I solve and simplify for A, B, C? I would multiply each term by d of x. What's d of x? The common denominator. D of x is everything put together. D of x is that factored denominator. I would multiply everything, multiply both sides of the equation, each term, because it would distribute, multiply by the common denominator, get rid of all the fractions, and then set up equations using the coefficients. using the coefficients. We'll look at another example. I can maybe add some more words, but if I can make it simpler, it's better. There we go. That's the whole process. I forgot step 8. Silly me. Solve and simplify for A, B, and C. Get rid of all the fractions. We don't want them anymore. We want to be able to solve. So multiply everything by the common denominator, set up your equations using your coefficients, and then solve. So let's try one, okay? Let me...
It's difficult to understand step.
Right. So it's going to be helpful if we can do it with a problem. So let's go here. Let's double page, and let's full screen.
Is this gonna be another?
Mm-hmm. What'd you say?
Is this gonna be another?
Partial fractions? I don't know. It could be endeavor, but it's really just pre-cal and we're reviewing. Guess it's not a bad idea. But I need to simplify the process. Here, let me write down a note to myself to try to think of a progress error in an endeavor. It's a good idea. Like what to do, how to integrate fractions. But we're going to be integrating more fractions in chapter 8.
So we just live.
I might just wait until chapter 8 and leave it, and I'll do it in chapter 8. Okay. Why or what should I do? Is it improper?
Plus 6
Improper?
minor x minus 3 times x minus 2.
Okay, alright, hold on. Guys, is it improper?
No,
No. Why?
because
Bottom is greatest, right?
Yeah.
Okay. Should I use U sub?
No.
No, bad idea. Why?
2x minus
Yeah.
5.
Should I use splitting up? Nothing to split up, only one on top. Arc trig. Maybe, except what did we see about this example earlier? Did we? Did arc trig work?
No.
No, I tried arc trig and then I said, no arc trig, no arc trig, no arc trig. So therefore I can't use arc trig. So we're going to use partial fractions. So then partial fractions, this is the one we did yesterday. But I want you to see the steps on an easy one before we go to the next one. So I can say, okay, Ethan, you already said it. This is 1 over.
1 over x minus 3. 1, 2, minus 3.
If only I could split up. Right? So you guys tell me, remind me, how do we do it?
A over 1 minus 2. Minus 2. Plus.
AB over.
X minus
You see what I'm doing? I looked at my denominator and I said only linear factors over here.
Both sides times x minus 2.
So then I just needed to set up however many for each of my factors. What do I have? Well, I have x minus 2 to the 1 and I have x minus 3 to the 1. That's all I have, so I don't need to do anymore. Just one of each. Why did I do AB? Because I need to do 1 degree less. So linear goes to constant. Just constant A, just constant B. So now what does my solving step say to do over here? But how?
Multiply each by denominator.
What's my denominator I'm going to multiply by?
X minus 2 times x minus
I need to multiply everything, right? When I multiply on one side, multiply on the other. So then when I do that, I'm going to have to distribute. Okay, what do I get on this one?
ax negative 3 over x minus 2
X minus 2 cancels, right?
over x minus 2.
No, a times
sorry.
x minus
What's on this one?
3. 1.
1. What's on this one?
B times x minus 2.
Does that make sense?
Yeah.
And then set up equations using coefficients. Well, wait a minute. Hold on. I need to split up. Split up what?
A times x minus 3a plus bx minus 2b. And the put x together, x coefficient together.
Yeah, I need to figure out what are my coefficients of x. Well, coefficients of x are a
A plus b
plus b.
times x minus 3a plus 2b.
What do I mean by set up coefficients? Well, guys, I have my x term. And my constant term. And over here,
So
I need, here's my x term. Does that make sense?
A plus, yeah. A plus b equals to 0.
Yeah, 0.
Minus 3a minus 2b equals to 1.
Hmm. So then I can solve.
Yeah, the first one times 3 and plus second.
Yeah, I could do that one. So I could do times 3.
So A is equal to 1, B is equal
So 3a minus 3a, whoosh, negative 2b plus b.
B equals to 1.
I think negative 1.
to 1.
Oh, negative 2 plus. My bad. Positive 1.
A is equal
equals
to
to negative 1.
Yeah, because a plus b is 0, so then if b equals 1, then a has to equal negative 1. So then what? Well, now I have my partial fractions, right? And technically, we had already done this one, guys, but I wanted you to see us do it one more time with the entire process. So then I would take my integral of 1 over x squared minus 5x plus 6. I could make it equal to a, negative 1 was over. Careful, make sure you do the right one. B over now so much easier. Because then I could think about each one individually. I could set his u equal to x minus 2 du is equal to 1 dx. His u, or if I want to, I could call it v, is x minus 3 dv is equal to dx. So I have negative 1 over u, so what's my integral?
Negative ln times negative u.
Negative ln of, right? U plus ln of v plus c. And then just plug in. What's u? Anyway, do the steps make more sense now as to why and how? We try, it doesn't work, so then we try partial fractions. Now, maybe there may be some problems in the future that are so complicated it doesn't work then either, but we will hope that is not the case. Uh-oh. I'm gonna zoom in on this one, that okay? Alright guys,
It's minus 1.
what do we do?
So you have both kind of factor, right?
Uh-huh. How would I rewrite it first? Can't I factor one more? Make it
Yeah,
easier?
Yeah,
x
x
to
times x minus 1.
On top. I guess I could pull out 2 to make easier. Do you want to pull out 2? I don't know. Don't have to. Now, if you wanted to make sure we weren't doing silly work,
It's minus
oh, minus 4, thank you, Mandy. My factoring today is bad. I don't know why. Calculus AB too. Bad factoring. Guys, it's never a bad idea to make sure that you're not doing too much work, meaning, well, hold on. Does this have any zeros? Can I factor anymore?
4.
No, because minus 4 square root, imaginary numbers, no. This one, 1. Well, 1 would make 0 here. What's 1 minus 2 minus 4? Oh, not 0. If 1 was 0, then it means I could factor and I could simplify, but I can't. I could try 0, 0, 0. No. These are vertical asymptotes. None of them will factor. No holes. So what am I stuck with? Hold on. Why don't I just do U substitution?
It's too difficult.
I don't know.
Complicated.
What would you think of if you had thought of U substitution? You don't have to write down, but do you mind if
X or minus 2x minus 4 is used.
you would try to FOIL, right, and see what you have? Make easier.
Um,
So I could do x to the 4th plus,
Maybe it can work.
I know, now Ethan's thinking, huh?
Because the power,
No, cannot.
Do you see why not? Because you're like, oh, maybe it'll,
This
Oh,
next
no.
to- Yeah.
but it's worth a try, because if it did work, did we just save ourselves lots of time? Yeah, but it doesn't work. Because if I did make U my entire denominator, no. Could I split up?
Yeah.
I could, but if I split up and I have x to the 4th, do you guys see that denominator? Was that going to be arc trig? I hope not, right? So we're just going to say, okay, splitting up isn't working, arc trig isn't working, U substitution isn't working, so what do I do? I shortened fraction. What could I say? FRCTN. Anyway. Guys, what am I going to do?
A over X. Separate those.
How many do I need?
3.
3, right? Okay, so I have x minus 1, and they're all to the 1, right? So I don't have to worry about doing repeated factors. So I have x minus 1, x squared plus 4. What's on top of x?
A.
X minus 1?
B.
X squared plus...
这样很厉害。
Doesn't make sense. I need constant because I need 1 less than linear, 1 less degree. 1 less degree, x to 0, 1 less degree, ooh, x to 1.
So, cx plus d is it's just like the rule there?
Yeah.
Or,
It's basically like the rule. It's because, Mandy, remember, if the degree of the top was tied, like if x cubed over x cubed, I should have divided. So I don't want x squared over x squared. I want 1 less, so I want x to the 1. But we need to make general, so to make general, I need to do a whole line. Because it could have been a line. It couldn't be a quadratic, but it could be a line. But if it was quadratic, we should have divided, so we wouldn't have it. Yeah. So then coming back. Now what? What's my step say? Multiply
By the denominator.
by the denominator, good. So I have x times x minus 1 times x squared plus 4. When I distribute here, everything's gone, right?
Yes.
When I distribute here, what's gone?
X times x negative 1 times x squared plus 4
Good.
plus bx times x squared plus 4 times cx plus d times x minus 1.
It's not good.
Not a good one, I know. And harder than homework, but if you get this one, then homework shouldn't be too bad. On 34, right? So then oh no. What do I need to do? So I'm going to have x cubed I'm trying to go in order. X cubed minus x squared plus 4x minus 4 is going to be first one, plus b times x cubed plus 4x plus now what? Equals.
C part. The C. Yeah.
Yeah, I have to keep multiplying, huh?
Yeah.
So then I can make this bx cubed plus 4bx. I could make this cx cubed minus cx squared plus dx squared minus dx. Double check. Cx cubed minus cx squared plus dx squared
Yeah.
minus dx. And then this ax cubed minus x minus ax squared plus 4ax minus 4a, right?
So
And this is all equal to, what do I need to do?
for a is equal to 1. And then I just plug it in.
Where are constants? Constant?
For a, yeah.
Oh, I already have
There's
one,
only one.
because it's only one. What's going to happen with my x squareds? What does it equal?
0.
Right? So I have to set up equations so I can say, okay, let's start with constant. So negative 4 has to equal what?
Negative 4a.
Negative 4a. Ooh, that's going to be nice, right? Okay, hold on. Next one. X, negative 2 has to equal, now I'm going on to x. Negative 2 has to equal
4a plus
4a plus 4b minus
minus
d, right? 4a plus 4b minus d. Do you guys see what I'm doing?
Yeah.
I have to take coefficients, right? What did I not cross out? Oh, that one. Then I have, x squared is 0. So 0 is going to have to equal negative a plus b plus c. No, not plus c. Yeah. No. I'm doing wrong ones, aren't I? Hold on. Negative a
It doesn't equal to b.
minus c. Yeah, you're right. I was wrong. Minus c plus d. And then the last one is, what's coefficient? 1 equals black. A
Plus b.
plus b, that's the one I missed, huh? Plus b plus c, done. So what do?
So
I solve it as much as I can. So I say a equals 1, then I can plug in 1, plug in 1, plug in 1, and I solve my system of equations with substitutions and all sorts of things. But what do I end up getting? An integral that is so much easier and possible. Now, good news is, question like this will not be on BC test. Good news is, question like this, right, Ethan? Not on homework. But easier ones are. So try to understand the hard one to get the easy one. Good?
yeah,
I'm going to go ahead and keep playing on this problem. You guys need to go to class though.
yeah.
I know you don't want to because this is so fun, but it's okay.
My art teacher is so mean.
Actually, they give us
Every time my
Did they give you a hard one? A quadratic?
no, I think they're quadratic. But I just don't got it. I didn't get it. It's very easy. Sometimes like I did.
How are you get in the room? Wow. Oh.
Guys, this is.
You know this, Mr. Shanks. This should be easy for you.
You should be going like to everybody who asks you this. Elementary, my dear Watson.
No, I think it's.
Do you at least know pre-calculus?
Mr. Shanks,
No, I mean, I did it at one time,
so
but it's been a really long time.
What do you have right
how's this study? The test and
There's no test.
Oh, you're doing this because you want to use, oh, I understand.
the chapter 5
Yeah.
Oh, yeah, she's.
We have which was why? It's not good. Do you have any football players in your class?
It's just on the
I just want to make sure you know it now.
We had all the football players. So
This is good. What is it?
It's a
It's not a test.
yeah, it's on the chapter 5, right?
Yeah.
We're on chapter
Yeah. So you have 2 quizzes then, right?
5. And does it goes under the case back?
Oh, for homework
Yeah.
check, you can do lunch or after school. Yeah, because it wasn't done.
Pass, so
before
we
you
have
get
another-
that right back, right? Should we write it back?
I don't know if I like that.
Well, I'm here really early. I know. Who's here? Sunny.